done with like most major topics. So the stuff we're doing in the next like week or two is going to feel kind of like disconnected because it is. I wasn't sure we were going to finish all the material, so like one or two sections here and there I'm just going to skip to make sure we got through all the big topics. So now we have got the big dogs. So we're gonna go back and like clean up those things we missed. So I was kind of wrong. We could have done all the things on the way. It would have made more sense and felt more connected. So I kind of screwed up. I wanted to make sure.
That's what happens when you're a teacher.
So this is gonna feel like we haven't done this in a long time. It's not having to do with what we did, but that's okay. It's also like review. For what?
The acceleration.
It's not really a formula. So this is going back to physics with the position, velocity, acceleration thing. Remember that if you position, velocity, and acceleration. To go down this list, you take the derivative. To go up this list, you integrate. So, like, what's the derivative of velocity?
Acceleration.
Yes. What's the integral of acceleration?
Velocity.
What's the derivative of acceleration?
Infinite. Jerk.
Jerk is like when you're driving in a car and the person can't drive.
Oh, right.
You know the bus drivers that go like,
Oh, yeah.
And then it jumps.
or like if you were around a teacher, let's say, your car, you'd probably jerk. Just as an example, I don't know. Is it too soon to joke about that, Ben, or are we?
No, it's been a couple months.
It's still a
Are you
little
laughing or crying?
I've had a joke about birthday.
What?
I've had a joke about birthday.
Okay.
No, day zero, actually.
Okay. So, I am giving you acceleration here. And I want to know the position function, S. So that's kind of weird too. You might write that. Position is S. You think it'd be P. But it's not.
It's not
It's not. So I need to find the position function and the velocity function. So I have to integrate the acceleration function. How do I go from acceleration to velocity? Integrate. So I'm going to integrate A of t, which means I'm going to integrate 2 times dt. What do you get when you integrate 2? Well, it's
You know. Oh, yeah.
2t. It'd be 2t.
Oh, yeah.
What's the derivative of 2t? It'd be 2. It would also be plus c. We haven't done plus c in a while.
Oh, no.
But there's no like limits of integration here. There's no boundaries. So there is a plus c, and it matters this time. We're going to find c. We never really worked with it before, but now we're going to. So this equals what? If I've integrated acceleration, what does this now equal? It equals velocity. And then try use of a mix-up. So then I use these two things to plug in. So this is your t, and this is your v. So this is 2 times 0 plus c equals what? So I think I can solve that. What is c? C is negative 23. So therefore, my velocity function is 2t minus 23. So when I first integrated, that's my velocity function, but I can be more accurate than that. I don't need it. I don't have to settle for like, oh, it's just some random constant. Because I have information here that I can use to find out what that constant is. So then I work through that and find out a little more specifically, and this is the velocity function that they'll be looking for. And then I want to find position. So what do I do from here? It's like the same exact process, right? I'm just going to do it again. So I'm going to integrate B of t, which means I'm integrating 2t minus 23. All right, what's the integral of 2t? The integral of 2t is t squared.
Oh.
So t squared, and then the integral of negative 23t, and then what? Plus c. And what does that equal? S of t. It equals position. Because if I have integrated velocity, I'm going up a level, which puts me into position. With me?
Yes.
So now I'm using this pair of numbers. This pair of numbers. So when t is 0, most of the time they make 2 zeros. It's like a fairly easy calculation. When t is 0, S is 132. Still with me?
Yeah.
So again, I can solve that pretty easily with C. So C is 132. What thereafter is what is the true position function, precisely including what is C. So you want to say, okay, S of t equals t squared minus 23t plus 132. So these two things that I have asterisks by are the two answers that they're looking for. So there's 3 different kinds of problems on this worksheet. That's the first kind. But that's it for that kind. Questions on 1? Try 2. So I'm thinking like I'll do one of each kind and then you do one of each kind. Yes, try 2. It's the same thing. Alright.
Oh, okay. Oh.
Didn't see me come in. You didn't see me come in.
I mean, like,
You've been here like for a while, right?
what would I do there?
Are you guys home or what? I was talking about that. I played golf. That was awesome. Where are you home or what? Still not answering my question. Of course. Carlton Glen. Airport? So.
Wait, you're calling us airport? Yep, I'm just right there, of course.
It was like a team. They're a mile high school golf course.
Yeah, obviously. No, maybe then we'll. Is it cross country course?
You have to check me in golf today. You disapprove of Ben's choice. Alright, Jack, you alright?
Yeah. That's alright.
I've said it 50 times.
Yes.
Probably should have asked earlier. Check that. there's v of t for the first one. Second one.
Oh my god. I got it right. What's funny?
And then I would integrate that to get s of t. Plug in v0 and v negative 66. And those would be the two things I come up with there. How many I done with two? Did I go too fast? How many I got that right? Question on two? Not bad, right? What's that thing? I'm smirking. Do you have a question?
No.
You're still processing. Alright, jump to number 7. So all I'm doing there is adding a step at the ends, and I'm reintroducing speed. Remember what has to be true about speed? Has to be a positive number. Speed doesn't have a direction, so if I'm running 40 miles an hour forward or 40 miles an hour backwards, my speed is 40. Either way. But you start these the same way. You're going to get your V and your S, and then you're just going to plug in. So if I do 7 here, so I'm going to integrate A of t, integrate 2t plus c, and that equals velocity. Same as the one we just did. And then I know that time is 0, velocity is negative 19. So 2 times 0 plus c equals negative 19 would give me c equals negative 19. So therefore, velocity equals 2c minus 19. So then all I'm doing now is say, okay, plug in for the given value of t. So the question is basically, what is the velocity when t equals 4? And then also, what's the speed when t equals 4? So the velocity of 4 equals, what's 2 times 4? Is 8. 8 minus 19 is negative 11. And then, I don't know how to, I'm just going to put speed of 4. You can't use s, because that's the position. But what's the speed of the velocity of negative 11? It's positive 11. How are you doing? You can process it. I'm not done. Calm down. I was just checking in with you. Alright. And then just do the same thing to get position. So the integral of velocity, the integral of 2t minus 19, which is t squared minus 19t plus c, and that equals your position. It's really annoying that s position. I don't know if that kind of authority. And then I know when t is 0, speed equals, or I'm sorry, position. Position is 78. Therefore, c equals 78. If I go too fast, am I okay? Or good? So then position is t squared minus 19t plus 78, and I want to know the position at 4. So you're just plugging 4 in What's 19 times 4? So we got t squared, so 16 minus 76. Negative 60. Negative 60 plus 78. We get those? Alright. So that's like not that big of an extra step, right? Just plug in when you get the two equations. Try 9. Jump to 9 just because I ran out of room here. I mean, you're going to have to do both anyway.
Chod.
What about some internship thing this time? Mackenzie's not leaving. You're not leaving anyway. Yeah. Oh, so I have to sign up for like that. You two. Then you third. Then you. You guys. I really think that's it. So there won't be a test before you guys leave. Unless you guys don't participate. Because I can see you just being like, well, the test, I don't have to worry about this. So if you keep doing what you do the work in class, you'll be good at Friday. Decide you're just gonna show up and be like, oh, there's no time.
So we so
Yeah. Yes. So like somebody in my second hour might come so that they can, like they're really close on the graded. So they're thinking of, I don't know if anyone's gonna actually, but if you want to keep coming and want to take this time, next test is an attempt to push your grade.
Okay, so
Unless you stop doing something.
oh,
Right.
that's not what it's right.
Help me help you.
Help. So we're gonna just keep them.
Wait. But the test isn't this week. Oh. I see. Are you gonna do that or you just throw out a hypothetical? Doesn't really matter.
Because like some reason if I don't have that, why would you want to do that? I'll be.
I thought you were doing it.
Yeah.
So,
Gotta work around. You have to work around the dude. What the heck is wrong with you guys? What? He's saying you got back in the You got your well, yeah, but I already worked on it.
You already worked on it.
Yeah, but then you didn't go home and sleep.
please hear it. So, after Friday.
I know.
You like that freedom? That'd be great. Go back to that.
Dude, Trent. I still have to learn to help him. So, dude,
I hear you.
you have an option not to go. Yeah.
Man wants to learn. Let him learn. Remember, Trent's the one that took like a week off because someone like 7 rooms away and it could possibly go to the Wait, why was it? It was like not even really.
You can take 3 days.
Yeah, but why? Weren't you like a contact of a contact or something? Like
Yes.
kind of ridiculous.
Yeah.
Oh yeah. Sorry, I have a moral opposition to testing. I prefer a 3-day vacation. It's freaking hurt your nose. And maybe learn how to deviate symptom because one side when I test I can go like sky high. The other one. Mr. Davies, what's up? Hi, Emily. Okay, thanks. Bye. What? Is 9 okay? Ethan, I admire your outfit. Where did I add it to? What? I'm integrating.
It's so hard.
Sometimes I'll just randomly say something. So see what they do. That's another one though.
I'd be like playing that and he'll be like, oh,
It's hard to talk to you sometimes.
no, Jackson said, we could just
What can I say?
sing a song. But it's really it'd be like,
You guys get 15 for velocity? That speed would also be 15.
nice.
Who would do that?
Yeah.
Yeah, it's hard to teach you sometimes.
No. I'm a ball.
From what?
Scale
That version was pretty funny.
up 1.1 now. We got a minor upgrade. Minor upgrade.
Would you like to downgrade?
You got that. He got you.
What would you say right now?
Crack.
Right now.
I guess I do crack. No, since I'm not computer class. This time. And like, how long's the reload?
What did you run? I got it saved here. Yeah. There. So it's negative 8.
What?
I just wrote, I had 81 here. And then I wrote 18 there. What's the word for 9? Question on 9? 81t. Negative t to the third plus 18t squared minus 81t. Is that okay? Alright. Go to like the back where we wrote that little shit. So let's say we have something like this. This is a velocity function.
Someone would
Okay,
he's
okay,
a
here we go.
That
guy, yeah. I got it. Simmons. Oh, dude, I remember this stuff.
Because it's existence and displacement.
Sadly.
Alright, so distance versus displacement. Stop talking, please. It's velocity. You want me to write time down here for you?
Yeah.
Feel better? So, distance versus displacement. If I'm standing right here, and it's 10 feet from me to Zeller, and I walk over to Zeller and I help him, and then I walk back right here, how much distance have I covered? 20 feet. 10 feet there, 10 feet back. That's distance. Displacement would be where am I in relation to where I started? 0. Right? So like this 15 and 4 here, this is like I went 15 units forward, and then I went 4 units back. So I walked 15 feet over to Ryan. Ryan threatened to punch me, so I stepped back 4 feet so he couldn't reach me. How much distance did I cover? 19. What's my displacement? 11. See the difference between those two? So I drive 10 miles to Ann Arbor, I drive 10 miles back. What's my displacement? 0. What's my distance? 1. Does that make sense what the difference is between those two? Okay.
Yeah.
So, the key here is where that happens, where the velocity is equal to 0. Because if you're above, you're moving forward, and if you're below, you're moving backwards. So go to number 13. This is the third kind of problem on the sheet. So they want the displacement and the distance traveled over the given interval. But almost every time you see this question, there's going to be some part of your trip that you're moving forward and some part that you're moving back. So we're going to find the velocity function. We're going to sum equal to 0, figure out where it's positive and negative, and go from there. So to find the velocity function, I'm going to integrate acceleration. Integrating 6t minus 28. Which would give me 3t squared minus 28t plus c, and then that equals velocity. And I can plug in my info here. So when t equals 0, velocity actually equals 0 also. So that's like an initial velocity of 0. Yeah, so c equals 0. And your velocity function is 3t squared minus 28t. Well, if my velocity is positive, which direction am I moving? Like forward or to the right? Yeah. And if it's negative, which direction am I moving? Backwards or left? So I need to know where the velocity is positive or negative, which means I better set it equal to 0. And solve. And you have your calculators. So throw that in solver. And see what you get. I got 28 thirds. Make sure you do 28 thirds, or you want to just trust me. Oh yeah, I got 28 thirds and 0. Why did I cross out the 0? Because the problem is asking between 5 and 12, and 0 is not 25. So the integral needs to be split. 28 thirds is between 5 and 12. Like how many times does 3 go to 28? 9 and a little, 9-ish. So that is between 5 and 12. Right? So this is just like when we found the areas. You have 2 endpoints and a spot in the middle. So I need to make 2 integrals. So I need to integrate 3t squared minus 28t from 5 to 28 thirds. Figure out what that is. And then I need to integrate from 28 thirds to 12. And figure out what that is. So I'll give you a second to put those in. I would probably put it at approximate. I was exact. It's pretty messy. So I got like negative 181.5. And then for the next one, I got 118.5. So just make sure you either got those or you know how to get those. Over like 27. That's I would put it in approximately. I think the decimals are a lot easier to work with. Trevor, do you know how to do that? So you go mode. Yeah, scroll down. It's off the screen a little ways. Go to exact approximate. You gotta hit enter. And then you gotta hit enter again so it saves. So there's the 2 things I got. And then my distance is the absolute value. My distance is 181.5 plus 118. I ignore the direction. I want 181.5 backwards. I want 118.5 forward. I actually traveled all that way, so I add up those 2 distances. Let's say 300. So you just make both parts positive, no matter what. displacement, you add them up like as they are. Negative 1 with the positive and negative signs. That's negative 6. Question now? I think I can go over here again. Check, we're right. Okay, that's all I got. Let's work.
What? You get a little bit of everything.
Yeah, what are you doing?
What general contract?
Ryan, what are you doing? Oh, the general contractor.
You know.
Yeah, you told me about that.